Hi guys, sorry that I'm not there with you guys today. Hopefully I'll be back in a couple of days and we'll be able to help you out. In the meantime, you are going to have a video version of me explaining what skill 15 is, factoring by grouping. The nice part about factoring by grouping is that it is something that you guys are actually familiar with. We touched on it a little bit on Monday in the notes when we were factoring things that had 4 terms. So we definitely would consider this probably a little bit more a review, so it's kind of a good lesson for you guys to be able to work through together. On the screen you can see that we're working with skill 15, so you guys should have your notes out already. And you can start filling in the work that you can see. So step 1 is to put it in standard form or equal to 0. These are not going to be quadratics, so they are not going to be ax squared plus bx plus c like we're used to. When we're talking about standard form now with these, we should be thinking standard form more, start with your highest exponent and work your way down. So standard form has to be equal to 0. Number 2, look for a GCF. Taking out a GCF always makes all of your terms smaller, they have fewer factors, and so it'll make the work easier. If you don't take out a GCF at the beginning, you will have to take out a GCF at the end, but there will always be a point in time where you have to take out a GCF. Number 3, you're going to group the first 2 terms and the last 2 terms together. You're going to put them in parentheses, and what I want to draw your attention to is notice that in the second set of parentheses, that sign, and if you're looking at number 1, that sign for negative is in the second set of parentheses. I am encouraging you to be really aware of the fact that the sign needs to go in the second set of parentheses and stay connected to that coefficient. You're going to look for a GCF in your first set of terms. You're going to look out for a GCF in your second set of terms. And then you're going to put the GCFs together in a set of parentheses and what is the same in a set of parentheses. And then the new part is that we're not going to be done. We are going to look to see if we can factor it any farther. You are usually going to be left with binomials. And after the practice that we had on Monday, you should realize that if we're being asked to factor binomials, you're being asked to see if there is the difference of perfect squares. So let's go on to number 1. Check and see, first of all, is it in standard form? And it is. All of the exponents are going down. Then you check to see if there's a GCF. There is not a number or a variable that this has in common. So that means that you're ready to jump to number 3, which is grouping. Put the parentheses around the first 2 terms, parentheses around the second 2 terms. What is your GCF between x cubed minus 2x squared? You take out an x squared, and you're left with x minus 2. Second set of parentheses, your GCF should be a negative 9 because you never want your first term to be negative. And so you should be taking out a negative 9, and you are left with x minus 2. In this set of parentheses are your GCFs. Your first GCF was x squared. Your second GCF was negative 9. What is the same? Notice this is x minus 2, and this is also x minus 2. That should happen every single time. So you have x squared minus 9 and x minus 2. X minus 2, you're not done. That is a binomial. You need to factor that binomial again because it's the difference of perfect squares. Remember, you're looking for a difference, which means subtraction. You're looking for numbers that are perfect, like 9. And then you're looking for the fact that there's an x squared. So x squared minus 9 becomes x plus 3, x minus 3, and x minus 2. Moving on to number 2. You are going to look to make sure it's in standard form, which it is. You are going to look to see if there is a GCF. If you look, 12, 24, 8, and 16 do have a GCF. So you should be taking that out. Again, I made a note there, GCF now or later, but it needs to come out at some point. So that is up to you. We're going to continue as if we didn't notice there was a GCF. So your first set, you're taking out a 12m squared. Your second set, you're taking out a negative 8. Notice m minus 2 is the same. It has to be the same. Group your GCFs together, 12m squared minus 8, and group your sames together, m minus 2. But hopefully you notice with 12m squared minus 8 that there is a GCF. What can you take out of 12m squared minus 8? What do they have in common? You can take out a 4. If you take out a 4, you are left with 3m squared minus 2 and m minus 2. Can you factor 3m squared minus 2 farther? The answer is no. There is not a perfect in there. 3 and 2 are not perfect. So that means that you are done with number 2. You cannot factor that any farther. I want everybody to take a minute or two and go ahead and try number 3. And so hopefully the substitute teacher will go ahead and pause the video at this point and let the students try number 3 on their own. Okay, I'm back with the answer to number 3. I hope you noticed that this had a little bit of everything. It had a GCF of 2 overall. Grouping got you x squared minus 1, 7x plus 8. And x squared minus 1 was the difference of perfect squares. So 2, x plus 1, x minus 1, 7x plus 8. Hopefully you got there. Again, pause the video and give the students a chance to do number 4 on their own. I'm back with the answer for number 4. This one didn't have anything special in it. There was no GCF. So you could just do factoring by grouping. B cubed minus 4, 6b plus 5. B cubed minus 4, I'm wondering how many of you tried to factor that farther. The reason you cannot is that it is a b to the 3rd power. That is not the difference of perfect squares, so you cannot go any farther because that's a b cubed. Okay, so it's not quadratic, it's cubic, so you can't go any farther, so that's your answer. Look at the next one, look at number 5. You have x's and y's mixed in. Multiple variables should not throw you off. Start with the same work. Is it in standard form? We don't really have standard form when you have 2 variables, so trust me, it is. Is there a GCF you can take out of all 4 terms? There is not. So what is the GCF you can take out of 3x squared minus 6xy? You can take out a 3x. What can you take out of your second set of parentheses? You can take out a 5. So 3x plus 5, and you're left with x minus 2y. Neither of those are the difference of perfect squares, so that means you're finished. Go ahead and pause the video and let the students work on number 6 on their own. Okay, I'm back. The answer for number 6 is shown there. You could do factoring by grouping, and that was it. So 6m cubed minus 7n squared and 5m squared plus 4n would be your answer. Second part of the lesson today is maybe a little bit new. Again, we touched on it on Monday when we were solving, but we didn't actually do more than just have a conversation about it. So if you go ahead and look at it, it says solve these equations by factoring. You're going to factor it as far as you can. Once you have it factored as far as you can, you're going to set each factor equal to 0. All right, so let's get started. When you look at number 7, you notice that every single term has an x in it. So x is your GCF. That's why there's this x pulled out here. You're left with something that has 4 terms, so you're going to factor by grouping. Take an x squared out of your first set, take a 3 out of your second set. So you will have x, that's the GCF from the beginning, and then you'll have x squared plus 3 as your GCFs, and your x plus 2, that is the same. You should always check to see if you can factor that farther. You can't. None of those are the difference of perfect squares. So that means you're going to set each factor equal to 0 and solve. GCF, so x equals 0, x squared plus 3 equals 0, and x plus 2 equals 0. The first one's already solved. X plus 2 is easy, x equals negative 2. The middle one takes a little bit of work. We haven't done this in a while. You're going to subtract the 3 to the other side. How do you get rid of a square? You're going to take the square root. What happens if you take the square root of a negative number? You have to use an I. And anytime you take the square root of something, you have plus or minus. So plus or minus I root 3. So here's the question. How many answers or solutions do you have? There are 4. You have 0, positive I root 3, negative I root 3, and negative 2. Remember, does that make sense with the fact that you have an x to the 4th power? We talked about that on Monday. So if you have something to the 4th power, you should have 4 solutions, which you do. Okay, well, let's go on to the next one. Number 8. First of all, is it equal to 0? No. So your first job is to move the 54x and the 108 to the other side. Then you look and say, okay, I can take out, or I can do factoring by grouping. So you can take out a 6x squared out of your first set and a negative 54 out of your second set. You might also notice that you could have taken a GCF out from the beginning. That is also a possibility. It depends on whether you noticed or not. But you could have taken, I think it's a 6 out from the beginning. If you noticed that, you could do that, and you'd have smaller numbers to work with. 6x squared is your GCF from your first set of parentheses. Negative 54 is your GCF from your second set of parentheses. So you have 6x squared minus 54 and x squared minus 2. Those are both binomials. Can you factor them farther? No, they're not the difference of perfect squares. Could you at this point still take out a 6 if you wanted to make your number smaller? Yes, you could, but it truly doesn't matter over here. You're going to solve it. So you're going to add 54, divide by 6, and take the square root of 9, and your answer is plus or minus 3. Then your other factor is x minus 2 equals 0. You would add 2 to the other side, and so you would have an answer of 2. Again, your original equation started as x cubed, and you have 1, 2, 3 answers, plus or minus 3 and 2. All right, I'm going to go ahead and have the teacher pause the video and have students work on number 9 on their own. All right, so we're back. If you're looking at number 9, you should be looking at the fact that, yes, it's in standard form. You probably should take out a GCF from the beginning. Your GCF of your whole thing is an x. So GCF of x is x equals 0. That's where you get this answer from, x equals 0. You're going to do factoring by grouping. And so you would have 2x plus 1 and 2x minus 1, because that's the difference of perfect squares. And then your other answer should also be 7. So 4 answers, 0, negative 1/2, positive 1/2, and 7. Okay. You are going to have some time to work on your homework now. Remember, your homework is going to be your assessment review. You guys will have a test on Monday. So the homework, again, is the assessment review. It'll be due on Monday, and Monday you will be taking your assessment. And so the rest of the class period should be time for you guys to work. I'm sorry I missed you, and I'm sure I will see you again soon.